Today we're going to be working on solving systems by a method called elimination. Sometimes it's called linear combination or canceling out. Now there are 4 basic steps to using this method. The first step is you need to write your equations in standard form. Standard form is ax plus by equals c. The second step is I may need to rewrite equations so that one of the variables will cancel out. This is kind of an optional step. You might not have to do this. The third step is I'm going to combine equations to solve for one of the variables. In other words, one of them is going to be eliminated. That's why it's called elimination. And you're going to be left with just one variable, and you're going to get a value for it. And then the fourth step is a lot like the step in substitution. Once you find the value of one variable, you're going to plug it back into either one of your equations to get a value for the other variable. All right, let's kind of take a look at an example, and I'll guide you through this one in which we're going to follow these steps. Okay, the first thing is to write them in standard form. Now, you notice I don't have x and y, but I have other variables. Is that okay? Yes. Now, let me tell you a little secret. In algebra, if you have any variables other than x and y, you treat the variable that comes first alphabetically like an x term, and the other one is your y. So if I'm doing my alphabet, which one comes first, m or p? So you're going to treat your m like the x. Okay, and it really doesn't have any other difference to it other than I usually kind of think of it coming first. All right, so are these written in standard form? Yes. Okay, I have my 2 variables on the same side. Okay, the second step is to rewrite the equation so that one of the variables will cancel out if I were to put them together. In other words, this is kind of like a vertical adding machine. Okay, I'm going to add those 2 terms and add those 2 terms and add those 2 terms. Are there any that will cancel out? Do any cancel each other out? Yes, the 2p and the negative 2p will cancel each other out. That's what we want to happen. So do I need to change anything? No, I'm just ready to cancel them out, okay? Combine them. So here's where the math comes into play. 5m's plus 3m's gives me 8m's. Okay, these cancel out, which I wanted it to happen, equals, what's 24 and 24? 48. Okay, divide both sides by 8. What's m? 48 divided by 8. 6. All right, now that I know that m is 6, I'm going to go to my 4th step and plug in the value into any equation to find the value of the other one. Now, which one do I want to use? It really doesn't matter. I try to look for the one that maybe has the fewest amount of steps it might have. Okay, you might look at positive or negative numbers, but it really doesn't matter. Let's plug it into this first one. Okay, so I'm going to have 5 times what now? 6 minus 2 times p equals 24. Okay, do the math. What's this equal? 30 minus 2p equals 24. And then what I do? Subtract 30. And I get negative 2p equals, what's this going to be equal to? A negative 6. Okay. And then I'm going to divide both sides by negative 2. P equals 3. So your ordered pair is 6, 3. That's your solution to this system. Okay, so now let's look at a system which we don't have a nice cancellation right off the bat when you look at it. There's nothing here that I can eliminate. I can eliminate my x's, I can eliminate my y's as it's written. So we have to make some changes. Now, you could choose to eliminate the x, or you could choose to eliminate the y. That's up to you. That's your choice. But whatever you do to one of your equations, you have to do to all terms in that equation. So in other words, I want to cancel out, let's say, for instance, the x's. So if this is a 2x, I need this to be a negative 2x. What would I have to take at times to get it to be a negative 2x? Times 2. So I have to take everything times 2. Okay, so I'm going to distribute my 2 and rewrite my new equation. I get a negative 2x plus what? 2y equals 2. Okay, then I'm going to rewrite my other original underneath it. Now, some people just rewrite it down below, but if you do that, you've got to make sure that I don't want to use that one again just yet. Okay, that's the only bad part. If you do that, if you write it below it, you need to make sure that you don't really want to use the top one yet. Okay, so either way, now I'm going to go to my second step, or third step, I'm sorry, is to combine them. Cancel out. How many y's do I have here? 3y's equals 0. Same thing here. They would cancel out. I get 3y's equals 0. Divide both sides by 3. Y is equal to 0. Okay, then what's the last step? I plug it in. Does it matter which equation? No. It doesn't matter which equation. Let's plug it into the first one. Negative 0, which is there such a thing? No. Plus y equals 1. So what's y equal to? Or excuse me, I did the wrong one. My bad. Okay, so take negative x. Let's get rid of that line if I can. There we go. Negative x plus 0 equals 1 because I want to substitute those 0 in for the y. So I have negative x is equal to 1, but what's x equal to? Negative 1. So my ordered pair, my solution to this system is negative 1, 0. Let's talk about some other special situations. If I end up with a negative 12 equals negative 12, is that a true statement? Does negative 12 equal negative 12? Okay, so then your solution is going to be like when you graphed, you had two lines that were the same. Will be all real numbers or many solutions. But if I end up with a statement like negative 12 is equal to 0, that's not a true statement, so there are no solutions. So just be aware that if you end up that way, that you could have a many solutions. They call that infinite. Many or infinite solutions, and this would be no solutions. There's no solution. Okay, in this one we notice there's not going to be just one thing that I'm going to need to multiply them by to get it canceled out, but probably I'm going to need to multiply both of them by something. Which do you want to do, x's or y's? Let's do x's. Okay, so you kind of find the common multiple of 4 and 3. What's the common multiple? 12. So I've got to get this to a 12x and this to a negative 12x. So what would I have to multiply this by to get it to be a 12x? Times 3. And this one I'm going to have to multiply by negative 4. Okay, now I have to do the math. 3 times 4x is plus 6y, good, equals 24. Okay, now remember on this one, I'm taking it all times a negative 4 because I wanted to have the opposite of a 12x, which would be a negative 12x. So you get negative 12x minus 12y equals negative 36. Okay, now we combine them. They cancel out. What do I get for my y's? Negative 6y equals 36 times 24 be 12. Is that right? A negative 12. Find the difference between them because one's positive and negative. Divide by negative 6. Y equals 2. So I already know in my ordered pair I'm going to have a 2 for the y. Now plug it back into any of the equations. Which one you want to use? Let's do this one. It doesn't matter. You can use any equation that's given. Any of these, use any equation. I usually use one of the originals because they're usually simpler. They're not as complex. So I have 4x plus 2 times 2 equals 8. So I subtract 4 from both sides, and I get 4x equals 4. Divide by 4, x is equal to 1. Therefore, my solution to this system by using the method of elimination is 1, 2. Okay, that concludes our lesson today on using the elimination method in order to solve a system of equations.